Hello students, welcome to Shri Classes, lecture number 5. Today we discuss about graphical method of solving a pair of linear equations. I'll take about 3 to 4 numericals and let us see how to solve graphically if it is possible. For example, whenever we take up the graphical solving or the graphical method of solving pair of linear equations, we may end up with intersecting lines for which the solutions will be there, and we may end up with parallel lines where there are no solutions. Also, we may end up with coincident lines where infinitely many solutions will be there. Let us take the first example. Question asked over here is, solve graphically and state whether the equations are consistent. The two equations given are 2x plus y equals 6 and 2x minus y plus 2 equals 0. These are the two given equations. How to plot the graph? After writing the expressions or the equations, express y in terms of x. So y equals 6 minus 2x. I have prepared already the truth table. By taking the value of x as 0, I get the value 6. By taking the value of x as 3, I get the value of y as 0 here. So let me identify these 2 points are P1, P2, 0, 6, 3, 0. I think you understand how to prepare the truth table and how to populate the values of x and y. Next equation is 2x minus y plus 2 equals 0. Express y in terms of x, 2x plus 2. Prepare the truth table. 0, 2. If I substitute the value of 0 here, I get value of y as 2. If x is minus 1, y will be 0. I have taken one extra point here. 2 are enough actually. You can take extra point also. If x is 1, 2 into 1, 2 plus 2, 4. So P3, P4, P5 are the points for second graph. P1, P2 are the points for first graph or first equation. So let us plot these things. Here, if we see point number 1, P1 is 0, 6, 0, 6. This is P1, I have highlighted. P2, 3, 0. X coordinate is 3, y coordinate is 0. This is point P2. Joining P1 and P2 gives a graph of 2x plus y equals 6. This graph. Let us plot the points P3, P4, P5 for second equation. 0, 2, P3, x coordinate 0, y coordinate 2, this point. X coordinate 0, y coordinate is 2, this point. I think I have mentioned over here as P4. Let me try to, just a moment. 0, 2, this is P3. Yeah, it is correct. Next, P4 minus 1, 0. Minus 1 is x coordinate, this side. 0 here, this is minus 1. This is minus 1, 0. X coordinate is minus 1 and y coordinate 0. This one. This is P4. This point is P4. 1, 4, P5. X coordinate is 1. Y coordinate is 4, P5. So P3, P4, P5. These are the 3 points. Joining these 3 points by a straight line gives us the graph of 2x minus y plus 2 equals 0. What is the conclusion here? These two graphs represented by these two equations intersect at this point P5. At this P5 both are intersecting. Intersecting point is the solution of the pair of linear equations. So how do you get the values of x and y for the intersection point? Here, drop a perpendicular to get the x coordinate 1. Draw a line horizontal to the x axis or drop a perpendicular to the y axis. You get 4 here. I hope you understand how to get the values of point of intersection, x coordinate and y coordinate. dropping a perpendicular and dropping perpendicular or drawing a perpendicular. 1, 4, x coordinate is 1, 4 is the coordinates of the point of intersection, and that is the solution of both the equations which I have written. Therefore, solution is x equals 1, y equals 4. What else is the question? Solve graphically? Yes, we have solved it. What are the solutions? Ordered pair is 1, 4. X value 1, y 4. Are these equations consistent? As the lines are intersecting, the equations are consistent, or the system of equations is consistent. That's all. Anything else? One more thing. If I substitute the value of x and y in any one of these equations, LHS should be equal to RHS. Otherwise, this will no more be a solution. So, can I verify this algebraically? Taking one equation. Let's see here. I'll try to work out here. Take x is equal to 1, y is equal to 4. Substitute in equation 1. X equals 1. 2 times 1 plus y value 4 equals 6, which is equal to RHS. So 1 is satisfied. Similarly, in the second equation, if I substitute x equals 1, y equals 4, can I get 0 here? Let us see. 2 times 1 minus 4, y value is 4, plus 2 equals 2 plus 2, 4, minus 4 plus 4, 0, which is RHS. So, algebraically also, the solution satisfies both the equations, and hence this is a common point of intersection, and the point of intersection gives the solution of a pair of linear equations. These pair of linear equations are also called simultaneous linear equations. That is one more terminology. In RD Sharma, probably you may find with some questions stating that, solve the following simultaneous linear equations. So don't get confused with simultaneous equations. So a pair of linear equations and simultaneous linear equations, both the terminology is same and both are one and same. Yeah, we will solve the next problem. Meantime, you can note it down very clearly. When I say a plotting up of a graph, make sure that you plot in a graph paper, not in a paper like this, or a board or a paper. Okay, you should plot the graphs in graph sheets. Okay, thank you. Yeah, let us take the next problem. Solve graphically and state whether the system of equations is consistent or inconsistent. CBSE 2010, 2x plus 3y equals 6, 4x plus 6y equals 12. These are the two given system of equations. We have to plot the graph because graphical method we need to adopt. Express y in terms of x, 3y equals 6 minus 2x, y equals 6 minus 2x by 3. Prepare the truth table. Take the values of x. If x is 0 here, 6 minus 0 by y you get 2. By substituting the value of x as 3, I get the value of y as 0. This is the truth table. Identify these 2 points as P1, P2. P1 is 0, 2 and P2 is 3, 0. I think it is quite clear. Similarly, for the second equation 4x plus 6y equals 12, express 6y in terms of x, 12 minus 4x, y equals 12 minus 4x by 6, and prepare the truth table. Let me take the value of x as minus 3 here. Minus 3 into 4 is minus of minus plus 12, plus 12 minus 12, plus 12 plus 12, 24, 24 by 6 is 4. Similarly, substitute the value of x as 3, you get the value of y as 0. 3 4s are 12, 12 minus 12 is 0, 0 by 6 is 0. Identify the points P3 and P4. P3 is minus 3, 4, P4 is 3, 0. These are the 2 points. So we are ready with points to be plotted. Let's plot them. Here I have to take the scale just to have the I have taken a scale as 1 centimeter equals 0.5 units so that it is enlarged a little bit. The graph is enlarged a little bit. 1 centimeter equals 0.5 units. Y-axis also 1 centimeter equals 0.5 units. So here I have marked 1 centimeter, which will be the major mark in the graph sheet is 1 centimeter mark. Subdivisions of the same are 1 millimeter marks. I hope you know those things. In 9th standard you have studied that. Fine. So the first division is 0.5, 1, 1.5, 2, minus 0.5, minus 1, minus 1.52 continues, 0.5, 1, 1.52 continues, minus 0.5, minus 1, minus 1.52 continues. It's clear. Let's plot the points. P1 0, 2, the first point, P1, x coordinate is 0, y coordinate is 2, here this point, P1, this is the point, P1, 3, 0, P2, x coordinate is 3, y coordinate is 0, point number P2, this one. So these 2 points joined by a straight line, which is the line represented by equation 2x plus 3y equals 6. Is it clear? Let us plot points P3 and P4. P3 is minus 3, 4. X coordinate is minus 3 here. Y coordinate is 4 here. This is point P3. Okay. Next is P4 3, 0. X coordinate is 3. Y coordinate is 0. P4, which is similar to point P2, I think. See here, yeah, P2 is 3, 0, P4 is also 3, 0. I need to join the points P3 and P4 here, this point and this point. What do you observe here? Are these not coincident? Yes, definitely these are coincident. Therefore, I will extend from here to here, I join now. You can see these are coincident. So, this line is represented by equation 4x plus 6y equals 12. These 2 lines are coincident lines. I hope you understand this now. These 2 are coincident lines. So what are the solutions? If these are coincident, every point that lies on both these lines is the solution. As both are coinciding, it is as good as a single line, and you have infinitely many solutions, infinitely large number of points which lie on the line, and all those points represent the solution. Therefore, my answer is, solution is, as the lines are coincident, there are infinitely many solutions. Is it clear? Now, other question is whether the system of equation is consistent or inconsistent. Consistent, the intersecting lines represent consistent pair of equations. Coincident lines represent consistent pair of linear equations. Therefore, the system of equations is consistent. Also, the alternate name is dependent pair of linear equations. Is it very clear? Now, you have one interesting fact. Last time also I had highlighted. Can I simplify these 2 equations and see what happens? Just observe here. 2x plus 3y is equal to 6 here. By taking common in this, what do you observe? By taking common here, I'll write here. Here I'll write. No, not possible to take common. Let it be there. Okay. As it is 2x plus 3y equals 6. What about here? Is it possible to take a common? Yes, definitely it is possible. 2 I take common here. If I take 2 common here, it will be 2x plus 3y equals 6. So are these not the same equations? Yes, therefore, in order to get the coincident lines, these 2, the equations should be, what is that we call, the equations are equivalent equations. Both are equivalent equations, because if I simplify, I get the same equation. So this is all about coincident lines, and this is what my answer. And generally we write such answers on on the graph sheets itself, just below the graph where we plot it, or in a suitable place in a graph sheet. Okay, please note it down carefully and you solve on the graph paper. Thank you. Yeah, we'll solve one more numerical, and that is NCERT exemplar. Have a look at the numerical there. (38) numerical, NCERT exemplar. Graphically solve the following pair of equations. These two we have to solve it by graphical method. Also find the ratio of the areas of two triangles formed by the lines representing these equations with the x-axis and the lines with the y-axis. Very interesting question. Here we need to first we need to plot the graphs and then see which are the triangles formed by according to the question. So let's solve this one now. Given two equations are 2x plus y equals 6 and 2x minus y plus 2 equals 0. Express y in terms of x, y equals 6 minus 2x. Prepare the truth table. Take x is 0 here, y is x, 6. Take x equals 3, y equals 0. Name the points P1, P2, 0, 6, 3, 0. Is it clear? Next, 2x minus y plus 2 equals 0. Express y in terms of x, transpose this side. So y is equal to 2x plus 2. Take the values of x as 0, 1, minus 1. Respectively, we get 2, 4, 0. So the points to be plotted are 0, 2, 0, 2, 1, 4, 1, 4, minus 1, 0, minus 1, 0. These are the points to be plotted on the graph. Let's plot the graph first and then see. Here, just a moment. This is not required, therefore I am erasing this. Not required. Fine. We'll plot the graphs now. Point P1, 0, 6. X coordinate is 0, y coordinate is 6 here. So this will become P1. 3, 0, P2, 3, 0. This is P2 here. I am naming that point once again as C here. It's okay. Join these two P1, P2 by a straight line to get the line represented by the equation 2x plus y equals 6. Let us plot P3, P4, P5, 0, 2. P3 is 0, 2, 0, 2. This is P3. It's quite congested, hence I am not writing. I hope you understand that. This point is 0, 2, P3, circled point. Remember, to distinguish between the other 2 points. 1, 4, x coordinate is 1 and y coordinate is 4. This one with the circle. Minus 1, 0. Minus 1 is x coordinate is 0. So this is the point. So these are the circled ones are the 3 points P3, P4, P5 respectively. Join those 3 points to get the graph like this. So these 2 graphs are intersecting at point A here. What are the coordinates? From there, drop a perpendicular, draw a line horizontal. This represents 1, this represents 4. Therefore, the coordinates of the point of intersection are 1, 4. X coordinate 1, y coordinate 4. Means along the x-axis 1 unit and this is 4 unit. Is it clear? Fine. Now, let us try to understand the triangles formed by these 2 lines and the x-axis and y-axis. The first triangle, he says, the triangle formed by or bound by the 2 graphs, the 2 lines and the x-axis. See here, these are the 2 lines and this is the x-axis. Therefore, ABC, this triangle is the triangle formed by the 2 lines and the x-axis. Is it clear? Fine. Next, the triangle bound by the graphs and the y-axis is the second triangle which we need to identify. The triangle formed by the two graphs and the y-axis. You can see here A, D, and this is E here. A, D, E, this small triangle is the triangle formed by these two lines and the y-axis. Is it very clear? Now I can mark if you want. For example, this is one triangle and another triangle is this one. Yeah. Is it very clear? ADE, ABC. ABC is the triangle formed by the two lines and the x-axis. ADE is the triangle formed by the two lines and the y-axis. We need to take the ratios of these areas. In order to find the areas, you should know the base and altitude. So in triangle ABC, the base is BC. From here to here 3 units, from here to here 1 unit. Even though it is -1, the lengths of the triangles are scalar quantities basically. Those are nothing but the distances. So if I ask you to find out the distance between point B and C, definitely it is 4 units because distance is a scalar quantity. And hence BC equals 1, 2, 3 plus from here to here 1 unit, 4 units. BC equals 4 units. Altitude AM is the altitude here. For this AM, what are the coordinates of A? 1, 4. Means from here to here it is 4 units. So you have base 3 plus 1, 4 units and altitude 4 units. In triangle ABC, you have base BC equals 4 units and altitude AM equals 4 units. So you can find out the area here this point you can see here. So triangle bound by the graphs of x-axis and the graphs is triangle ABC. Area of triangle ABC is equal to half into BC into AM. Half into BC into AM. So half into 4 into 4, 8 square units. Is clear? Now, next smaller triangle ADE. In this, the altitude is this one. The altitude. Coordinates are 1, 4. So this much unit. From here to here, this is 1 unit. So what about from DE? The distance DE. From here to here 6 units. From here to here 2 units. 6 minus 2, 4 units is the distance of DE. Area of the triangle ADE equals half into DE into AN. DE is 4, AN is 1. So area of the triangle bound by the graphs and y-axis, which is triangle ADE, is given by triangle ADE is given by half into D into AN, which you get 2 square units. So we got the areas of triangle ABC as 8 square units and area of the triangle ADE as 2 square units. Take the ratios. While taking the ratios, you must ensure that what ratios has he asked for. In the question he has asked, find the ratio of areas of the triangle formed by the lines and the x-axis to the area of the triangle formed by the two lines and the y-axis. Definitely the ratio asked is area ABC is to area ADE, which means area ABC divided by area ADE. Area ABC is 8 square units, area ADE is 2 square units. So the ratio is ABC by ADE 8 by 2, 4:1. So ABC is to ADE is 4:1. This is the answer. See, dear students, there are many questions. Where you need to plot the graphs first and you need to find out the coordinates of the triangles formed by x-axis and the graphs, or the coordinates of the triangle formed by y-axis and the graphs. Many times you end up with such situations. So this question has explained to you very well what is the triangle formed by x-axis and the lines. Which is the triangle formed by the lines and the y-axis. I hope it is very clear. Okay. So please note it down very carefully. You work out in a graph sheet, then you will really enjoy that. Make sure that a slightest mistake in reading the coordinates may lead to a wrong answer in terms of the ratios. Generally remember, when such questions are asked, all these answers should be in integers. Of course, areas definitely positive integers. Okay, fine. First you note it down. I have a couple of points to discuss with exemplar numericals. About 4-5 are there, and I'll just discuss and then we'll close the session for this lecture. Okay, fine. First you note it down. See here, similar to the one which we solved right now, we have another 3 questions. Just I'll read it. Determine graphically the vertices of the triangle formed by the lines y equals x, 3y equals x, x plus y equals 8. Draw the graph of the equations x equals 3, x equals 5 and 2x minus 5 minus 4 equals 0. Also find the area of the quadrilateral formed by the lines and the x-axis. You must be familiar with the areas of trapeziums, areas of quadrilaterals, etc. Because you may end up with here a quadrilateral could be some kind of a trapezium where half h into a plus b should be able to give you the area of the quadrilateral formed by the lines and the x-axis. I am not sure. Please check it. Draw the graphs of lines x equals minus 2, y equals 3. Write the vertices of the figure formed by these lines, the x-axis and y-axis. Also find the area of the figure. Remember, you will definitely get such questions where apart from plotting the graphs, you may be asked to find out the areas of the triangles formed by the lines and the x-axis, or the area of the triangles formed by the lines and the y-axis. Please practice these questions also. Okay, we'll end this session over here, and for practice you must refer RD Sharma. I'll just scroll it up here. You can see there are so many questions, CBSE 2000, 2000 and you can see here there are so many questions. Which is this exercise? Let me check up this exercise first. Yeah, 3.2. Exercise number 3.2, RD Sharma, page 3.29. You have plenty of numericals. CBSE 2001, 2000, 2010. You can see here. Okay. I suggest you to pick up at least a few questions. Just a moment. Yeah, see here. 25th question. You can have a look at this one. CBSE 2002. Draw the graphs of x minus 5 plus 1 equals 0 and 3x plus 2y minus 12 equals 0. Determine the coordinates of the vertices of the triangle formed by these lines and x-axis and shade the triangular area. Calculate the area bounded by these lines and the x-axis. Many such questions can appear in the exams. Okay, please practice the previous year questions from this exercise 3.2, which is this one, 3.2. Please practice previous year questions of exercise 3.2 addition. Okay, fine. We'll end the session over here. Thank you. Please note down all the details in your 400 pages notebook, and we'll meet in the next lecture. Thank you.